Okay, here's your first assignment, man. Determine, and I'm going to go through, you're going to have to write it on notebook paper. It says, I wrote the directions twice, so stupid, okay. Determine whether each function is an example of exponential growth or exponential decay. So here's number one, okay. You can write down the directions if you want, it's up to you, okay. So y equals 100, 0.25 to the x power. So you're either going to write growth or decay. Now, if I take a number and I multiply it by a number less than 1, like 100 times 0.25, that number 100 gets smaller, okay? So this is less than 1. If you multiply by a number less than 1 and that has the exponent, okay, that's decay. Okay, number 2, y equals 7 over 8 and then 18 to the x power. Now here the 18 is bigger than 1, so greater than 1. So if I take something times 18, it's going to get higher, so that's growth. It doesn't matter what you start with, okay? When you take something times 18, it's going to grow. But when you take it times 0, something less than 1 whole, it's going to get small. Okay, y equals 0.2 and then 5 over 3 to the x power. Okay, now if you don't know if 5 over 3 is bigger than 1, well, you can go on a calculator, take 5 divided by 3, that's bigger than 1, okay? So, greater than 1 with the 5 over 3, okay? So it's going to be growth. Okay, and then the last one of these, we have y equals 0.7, then times 1/5 to the x power. Now, how about 1/5? Is that bigger than 1 or less than 1? Well, if I take 1 divided by 5, I get 0.2. That's less than 1, okay? So that's decay. Okay, number 5 and 6. Write each equation in logarithm form. So number 5, 3 to the 4th power equals 81. Okay, so you put the word log, and the first thing you do is circle your exponent, the 4. That jumps over here, and that's what it's equal to. That's the only thing that's going to go on that side of the equation. Now the exponent's base is 3, okay? So I put a little base 3 right there, that's a base. And then put the 81 product goes right before the equals. So that's it. Log base 3 of 81 equals 4. Okay, number 6, 8 to the power of negative 2 equals 1 over 64. Okay, so I put log, the exponent goes over here by itself. Then the exponent's base moves down to here, and then what it equals, the product, that's what that's called, goes right here, 1 over 64. Okay, I'm going to keep running here. Okay, evaluate each logarithm. So number 7, we have log base 7 of 343. You got to find out what that equals. Well, the way to figure out what a logarithm is equal to, you just take the base and start multiplying till you hopefully hit 343. That's 49, so if I times by another 7 and take 7 times 7 times 7, that's 343. So how many 7s is that? It's 3, so the answer is 3. Okay, number 8, log base 8 of 512. We're trying to do the same thing unless the directions change. Log 8, 512. Same thing, so you got 8 times 8, 64. It's 3, okay? Okay, number 9, log base 9 of 6,561 equals. So you got 9 times 9 is 81. Nope. times another 9. Okay, there it is, 6,561. So that's 4 9s, so it's 9 to the 4th power. Okay, number 10, same thing. Log base 2, and then after the log, you got a 1 over 16 in parentheses. Well, if I put a negative sign, I can forget about the 1 and just multiply 2's to get to 16. So 2, that'd be 4, 8, there's 16, so it'd be negative 4. I don't know, what I'm circling would be the answer. Okay, now I'm going to flip over the packet. Okay. I usually tear this off because it's hard to write when I get against the binder on the other side. Okay, now I'm solving each equation. Okay, solve each equation means you got to find out what the x equals. So in the first problem, it'd be problem number 11 on your drive. We have a base 3 to the power of 4x equals 243. Okay, now when you're solving for a x and x is in the power, you want to use this little formula here. So go 4x equals, and you're going to find what the x 3 to the what power is 243 by using your log divided by log. Okay, so the product goes on top and the base on the bottom. Okay, so 4x equals. Then I go to an online calculator. I know you don't have one of my calculators, so I'm going to Google a calculator. Just Google a calculator. Okay, and that pops up. So we'll go log 243 divided by log 3. Okay. Hit equals, you get 5. Okay. So 4x equals 5. Then you divide both sides of that by 4. 5 divided by 4, it's going to be a decimal. A lot of these are decimals. So 5 divided by 4 is 1.25. That's the answer. Okay, number 12. Okay, we have a base 3 to the power of x minus 4 equals 20. Okay, so again, we got to solve for our power here. Okay, so x minus 4, and the way you solve for a power is simply applying the logarithms, the log divided by log. So the product 20 on top, and then the base 3 on bottom. So x minus 4 equals, then I go log 20 divided by log 3, and we get 2.73. So plus 4, 2.73 plus 4 is 6.73. Okay, number 13. Okay, log base 5 of x equals 4. Okay. Okay, first off, you want to write this in without a log form. Here's how you write it out of log form. Whatever's in the parentheses goes here all by itself. Okay. And then this base 5 comes over here, and it's to the 4th power. Okay, remember a log's equal, whatever goes on one side of a log is the exponent. So something to the 4th power, and that something's 5. Okay, so 5 to the 4th. So I go 5 times 5 times 5 times 5. I got 625. That's all we have to do. Okay, that's what x equals. Okay, number 14. This one's a little bit dicey. 4 parentheses e to the power of 3x equals 200. Then off this side it says hint ln. Okay. Okay, now first thing you have to do before you go to the ln, you got to get rid of this 4. Okay, now it's in front of e, so you would just divide by 4. And 200 divided by 4 is 50, so we have 50. And I've still got the e to the 3x power. Now we're not going to do the log over log, because with e what I do is apply an ln to both sides, and then the e goes away, and I've got 3x equals. Now I have to find the ln of 50, the natural log of 50. So I go on this calculator, here's ln right there, ln 50, and I got 3.91. Then I divide both sides by 3, and that's like 1.30. And that's your answer. Okay, now let's go with your story problems. Now make tables. When something grows by a percent, I would suggest you make a table. Okay. So as I deposit $2,000 in a savings account, that account earns 3% interest per year. How much will be in the account after 6 years? Okay, number 15. So you want to make a table with your years and your dollars. Okay. You start with 0 years and you start at $2,000. Then when something grows by a percent, you multiply it, and you're going to take 100%, and interest means you add 3%, so that's 103%. So decimal move twice. So we're going to multiply by 1.03. Now remember, what we need to do is go out and find how much is in the account after 6 years. So I can stop, I have my answer after the 6th year. Okay. So after the first year, we take 2,000 times 1.03, 2,060. Second year times 1.03. Okay, $2,121.18 times 1.03. $2,185.45. Okay. Then times 1.03, and that's going to find how much we have after the 4th year. $2,251.02. Okay, times 1.03. $2,318.54, 2318. You put 54 or 55, I don't really care. And then the 6th year gives us our answer, so times 1.03. Okay, $2,388.10. Okay, and that's our answer. Okay, number 16. Okay, you deposit $200 in a bank account that earns 4% interest per year. How many years will it take the account to reach $230? Okay, so now I'm finding how many years it's going to take, and I don't stop till the money's now at $230. So we start with $200, and then we take 100% plus 4%. That's 104%. Okay. Okay, $208 times 1.04, $216.32. Remember, I just got to get to 230 times 1.04, $224.97. Okay, 233.97, that's exactly where I want to be. So I want to be at 230, but now I'm over it, so it's after the 4th year you're going to have that much. Okay, then you got some problems to work down there. on the end. Don't worry about typing up your answers onto a spreadsheet. Just keep the notes in your note. Just put it in your notebook and then hand it to me when you get back. Okay, thank you.